Hi guys, I'm Isaac and I am Shaft Dev and I'm back with another video. Today we're going to be looking at projectile weapons, specifically a rocket launcher. So if you've always wanted to create a rocket launcher that can fire a rocket and have an explosion, have your physics bodies actually react and go flying around the room, then this is the tutorial for you. It's a little bit slower this time. I've actually recorded it in line with my audio live, which is something I don't normally do. I actually speed up the video most of the time and then talk over the top of it, so it's a little bit more condensed, but this time I've done it in line, so it's a little bit longer. I've broken it up in 3 parts, so you can just skip to wherever you want to go if you want to learn something specific, like just doing the raycast and spawning the rocket, or anything else you want to learn how to make an explosion where physics bodies will actually react and your enemies will still take damage. As always, please like and subscribe, it really helps out the channel, and let's get into it. Okay, so if you want to make a rocket launcher and have an explosion at the end of it, there are a few things that you need to consider. The first one is that the objects in your world will need to be told how to react to it. So there are 2 types of objects that I have in this scene. We've got the enemies, represented by these red capsules, and the physics objects, just by these green boxes. So what happens when the explosion goes off? They both have the same function. The rigid body will take 2 variables, source location and force. And the source location will just be the location of the explosion, wherever that is, and apply an impulse, taking the direction and multiplying it by the force. With apply impulse, if you don't know, it takes a position and an impulse. So the position is the position on the body. That can be anywhere. 0, 0 will be at the center of the body. And it also takes a impulse, which is the amount and also the direction. So we want both of those things. We want the direction, and we also want it to be multiplied by a force variable so that it can actually get some power behind it and do something when the explosion hits. And on the kinematic body, we're going to run the same function, hit successful. We're going to pass in the source location. We're going to pass in the damage. I'm not going to do anything with the source location for now, but the damage, it's just a basic health check. We're going to subtract the damage from the health, check the health, and if it's less than 0, we'll queue free. So you might have noticed that the force and the damage are in the same position. I'm going to use the same variable for both. You could split it up if you want to, it's really up to you. The point is, we need to do 2 different things with each of these objects at the same time so that they react in a similar way. And if you wanted to extend this, you could as well with the enemies. Say once they're dead, once the health is reached 0, you could spawn in a physics version of them and apply the same function here and apply an impulse in the direction, maybe do a ragdoll kind of thing. It's all possible, but we need to make the explosion. So let's start there and work our way back to make a rocket launcher. I'm going to create a new scene. It's going to be an area 3D, and we're going to put a couple of things on this. Obviously, we're going to need a collision shape, and I'm just going to make mine a sphere. Yours can be any shape you want. I'm going to make it 2 on the radius just to give it a bit of like area of effect. This will be the area in which anything is affected by the explosion. The other thing we're going to want is an audio stream player, and that will just be in the area, not underneath the collision shape. A bit of a particle so that we can see what's going on, and also a timer. Okay, so obviously the particle is where we're going to get the visual. We're just going to make a simple one so we can see what's going on. So we're going to add a draw pass. We're going to add a quad mesh, and then in that quad mesh, we're going to come down and add a new spatial material. And in that spatial material, we're going to add a flag transparent. We're going to add the parameter of Y billboard, and then we're also going to add a texture. If you're using my demo, which you can download from my website, shaftgames.com, you can get all these particles that I've got from Kenny's website. Shout out to Kenny, makes really good stuff, which you can download for free from his website. And I've got these explosions here. Black smoke will be perfectly fine. I'm going to use black smoke 1, and there it is. So we're going to add also a process material. This is what will give the particle some direction. So as you can see, it's just falling right down. We're going to come down into the particle, and we're going to reduce the gravity, probably just like 0.2, and the direction will be y, 1, and x is 0. And then the spread, we're going to make that 90, and that'll just be everything above the x-axis, the x and z-axis, so it's only going to go up and around. If you make that 180, it'll go in every direction. Okay, and we're going to give it some initial velocity. So I'm going to start with 5. Seems a bit too much. I don't really want it to go past the bounds of the area of effect, just so you get a bit of a visual about where it's going to go. Okay, so the velocity is 2. The time is 1, and we're just going to make the explosiveness 1, and then probably turn up the number of particles from 8 to about 50, I think is probably enough. And the next thing that we need to do is just make sure that it's a one-shot, so that it just triggers once, and that's basically it. We'll rename this area node to explosion, and we'll save this scene under, I'm going to save mine under tutorials, rocket launcher, components, explosion. And the next thing we need to do is add a script. So for this script, we don't need to do too much. We've got to get those 2 variables that we had, which is a direction. We're just going to set this to be a vector 3, but we're not going to set it to be anything yet. I might just call this impact so that it's a little bit more ambiguous. I'll make it 10, and then we'll need to get access to the particle. So on ready var, I'm just going to call mine underscore particle, particles, and get access to the particles. So in the ready function, we'll need to make the particles start emitting as soon as it's spawned. So dot emitting is equal to true. We can delete the process function, we don't need that. We need to connect up the 2 signals for the timer. For the timer, we want it to be a auto start. 1 second is fine because that's going to be the time of the particle. And we've also going to need to connect timeout signal here. Connect the timeout signal. We're just going to call Q free. So once that particle is finished emitting, we can Q free and delete this. So that's that. And on the area, we want to call body entered. You might need to call area entered as well, depending on how you've set up your enemies and your objects. But for me, it's just body, connect body entered. So we want to, first of all, set the position of the direction. And that's going to be, actually I might rename that, to be fair, position. That's a bit clearer about what this is, because it's just going to be the position of the explosion. So the position is going to be equal to get global transform dot origin. No, it's a function, origin. Okay. And then all we want to do is go if body dot is in group. Now I've got one called weapon reactive. I've actually got 2 groups for each of my objects, just in case I don't want to do something to either one of them. Body.hit successful. We might just jump over to this and copy it across. It's going to be a little bit easier for me to type. And we're going to need to pass in the position and the impact. Okay, and I'll need to add in the other group as well. If you've got any groups set up, you'll need to add them as well, and I'll just copy the exact same function. So just so you're aware, in case you haven't set up groups, in order for this to work, so this is just going to help us break up our objects in our scene and only call the function on things that actually have it. So back to the explosion. That is pretty much it. We didn't set up the audio stream player. If you have a sound, you can add it. I've got one under tutorials, rocket launcher sound, explosion short. Area 3D is really good because the further away you are from it, it's going to be quieter. The closer you are, it's going to be louder. If you can hear that, I'm not too sure. Yeah, you should be able to hear that. So this is a really nice way of just getting that sort of to be louder, obviously, if it's closer, or be quieter if it's further away. You might need to play with the settings. I'm just going to leave it how it is, just to give you an idea of how you could make something like this work. Okay, so we've got the explosion. We need a rocket that's going to land and create an explosion. So the cool thing about this kind of thing is that you've got an explosion. You could use this, say, for a landmine, a rocket, anything really in your world, and it's separate from the actual rocket launcher itself. So this could be reused if you've got it. Okay, so let's make a rocket. This will be a rigid body scene. So I'm just going to create a new scene and add the parent node rigid body, and I'm just going to call that. And we'll need to add a mesh. I've got mine, if you're using my project, under primary AT4L and launcher. That's the launcher we want. Rocket.glb. So this is just a simple rocket that I made in Blender that's already oriented the right direction. If you're shooting this from a weapon, it will need to be facing the negative Z axis if you're not using this project. Just keep that in mind. So I'm going to make this local and just pull the mesh out and delete the parent scene because I don't need it. Okay, so the other thing we need obviously is a collision shape so that we can actually test collisions. And I'll just set this to be a capsule. We're not too stressed about the size being exact. As long as it's close enough, I don't think anyone's going to be able to tell the difference. Okay, we've got that. We're going to add another particle so that we can have some dust coming out the back. And we're also going to add another audio stream player. If you want to, that is. Okay, we'll start with the audio stream player since we're already there. The sound that I've got in my project is under sound, under Rocket Launch Tutorial sound. We've got rocket.wave. It's just going to drag that in, hit play. Sounds pretty good. For the particle, we're just going to drag that back to the end of this. I'm going to use pretty much the exact same technique, so if you're not interested, that's the wrong thing. You can probably just skip ahead. I'm at a quad mesh. I'm going to add a material to that. I'm going to change the size, obviously, down to 0.2, and we'll come back down into models, particles, black smoke, and we'll just add, that to the albedo, and then make sure that's transparent, and also billboard, so that we can see it anywhere. So for the rocket, I find it looks better if you untick local coordinates. That way it'll leave a little bit more of a trail. This will mean that the particles will just float in the air as the bullet travels along. So we're going to add a new particle material. Obviously for the gravity on this one, we want it to actually probably be in an upward direction, but very slowly. I think that might look best. The direction, obviously, we want it to be, we need to give it some velocity for us to see that in a Z direction. I like to turn the spread down a little bit so that it's just a little bit further out. And obviously we're going to need way more of them, so just add that up. So that looks okay. I think that's perfectly fine. We don't need to spend too much more time on that. I might just round this up to 10 so that we've got it there. You might need to play around with this to make it actually look good, but I'm not going to dwell on it. Okay, so we've got everything set up. There's a couple of settings in the rigid body you'll need to change to get this to work if you want it to actually hit something and react. So you've got continuous CD. I find that works very well if you turn it on, and you've got contacts reported. This is the number of contacts that the physics body will actually report. It needs to be given a value. I think it's probably better if it's more than one. I turn mine up to 5. I don't know, maybe it needs to be more. I honestly haven't really looked into it, but you do need it to work, and you obviously need to set the contact monitor to on. Those things are all there. The other thing that I think works really well is the gravity scale. If you have this at 1, it will just fall straight down. Now this is a rocket and we're trying to make it look like one, so it's probably got a bit of force behind it. Now there's a few different ways you could simulate that. You could turn up the speed that you launch it at, but Godot's physics system isn't really built to detect fast moving objects very well. There's a lot of documentation on how you get around that. I find for a rocket, just make it slower and it works perfectly fine. So, you know, for a regular bullet, not the best to use a physics object, but for a rocket, that's perfectly fine. I'm going to turn mine down to probably about like 0.1. And we're going to save this scene under rocket launcher components. I'm just going to save it as rocket. Okay, so let's add a script to this. We can delete the process function, and we're going to add a couple of variables here. So the first variable we're going to get is the explosion that we just set up. I'm going to go var explosion equals preload, and I'm just going to find that explosion in my file browser here under rocket launcher components explosion. Probably need to put the brackets in and just drag them in here. So now that we've got that, I'm just going to need to get access to the particles. I'm just going to use onReady var underscore particles, and we'll get the particles. Okay, so for this one, I'll do the exact same thing. I'm just going to make the particles emitting equal to true. Now for this one, they are actually already emitting, but it's just a safeguard in case we turn that off or it doesn't work, who knows. Then the next thing we need to do is just come over to the inspector for the physics body, for the rigid body, excuse me, and just grab this signal body entered and connect that up. Okay, so we're going to need to spawn our explosion when it makes impact with something. So what I'm going to do is create a variable called var w, that's short for world. By the way, it's just what I like to use. I get tree dot get root. This will give us the root node of the scene. And then we're going to go var e for explosion and just call the explosion dot instance. Okay. And then we'll also need to set the global transform of the explosion to be exactly where this rocket is. So e dot set global transform in brackets get global transform. And that'll just make it appear at the exact location that the rocket is impacting on. And the last thing that we'll need to do is w.addChild. So world.addChild, and type in E for the child. And last but not least, delete the rocket. It's as easy as that. And also make sure that, and I probably have to check this on the explosion, that these sounds are set to autoplay so that we don't need to actually trigger them when they happen. So just a little thing that I've forgotten there. Come back and set them to autoplay. The other thing with the rocket is that we don't want it to impact on ourselves. Now, for me, it means I need to untick this mask here so that it doesn't hit the player. For you, it might be different depending on the layer that your player is on. They might be completely separate. This might not matter for you, but for me, I need to do that for this to work. Okay, so we have our rocket, we have our explosion. So now let's go ahead and add a rocket launcher to our player. I'm going to come over to the projectile rocket launcher scene, and I'm going to grab the main camera. I'm just going to hit preview. I've got a weapon holder here, and I'm going to come down to weapons, primary, AT4L, and I've got the launcher here. It's spelled incorrectly, which is pretty funny, and drag that in. I'm pretty happy with that, where that is. I'm gonna right click on the model and just click make local. That'll just make the mesh available to me and I can start adding things to this scene. So the first thing that I need is something called a position 3D. This is very similar to a spatial, but it's gonna help us sort of determine the position that the rocket will launch from. So I'm gonna come out here and I'm just gonna drag this to the very front of the rocket. So that'll be the point on which we spawn the actual rocket to come from the rocket launcher. And that's that. I'm gonna call this rocket point. Okay, the next thing we need is an animation player so that we can play an animation when we shoot. I can't spell. Animation player. and we'll just add an animation called shoot with a capital. 1 second's probably fine. Come back over to the main camera, and I'll just change my snap to be something a little bit smaller because this will need to be a very quick animation. And we'll just come over to the AT4 launcher, come to the transform. I'm going to key in the base rotation and the base transform, so we have that. And at 0.1 second, I will key in the 20-degree rotation. I'm also going to raise it up a bit so that it looks like it's sort of stayed in position, which that does a little bit. Okay, then the next thing I'm going to do is just move this back a bit, key that in, and key in the rotation. I don't want that. And then as we go forward, we're going to rotate back down to 20. Rotate back down to 0. And then obviously at the end of, actually we'll make this, 1 second's fine. I'll highlight the 2 original points, and I'm just going to right click duplicate. What that will do is create 2 of the keys at where the blue cursor is right now. Okay, so it's probably still a bit too slow. I'm going to move these 2 together. Maybe make this a little bit faster. That looks pretty good. Okay, so let's also add an audio stream player. Not audio stream player 3D, but this time just audio stream player. And we're going to add a sound to the rocket launcher. We've got one here in sound. We've got rocket shoot. And I'm going to draw that in. I think this is quite loud, so I'm just going to reduce the dB down to like -7. Test that out. Yeah, that's pretty loud. And then I'm going to key in playing, create a reset, come down to where it says playing, and just toggle that on. So now that looks like that, and it will keep playing that sound until we leave this animation. It's a little bit annoying, but it is what it is. Okay, now that we've set this up and we're pretty happy with the way it looks, I'm actually going to save this branch as a scene. And I'm going to come that down, and in tutorials, rocket launcher components, got AT4 launcher. I'm going to correct my spelling here and just hit save. Okay, so now we can open up this, and we're going to add a script to it. AT4 launcher is fine. Hit create. Okay, so we've got a few different variables that we need to call here. So we've on onReady var rocket point. This is the point where we'll spawn the rocket. Equals rocket point. We've got onReady var anim player. I just call it anim play, and then just get anim animation player. And then there's 2 other variables that we need. These are a little bit special, and I'm calling them at the top, but you can call them in the function if you want as well. I'm just doing this for ease of, I'm just doing this to make the script a little bit easier to read. We've got camera.get viewport.get camera. And that'll actually give us the active camera, and then we create a raycast for that. And then we've got onReady var underscore viewport. And we've got get viewport dot get size. And this will be necessary for creating a raycast from the center of the screen. Okay, we've got current ammo. Do we need that? I think I'm going to leave that out. Okay, so the other thing that we need is the speed of the rocket. I'm going to make this an export variable. Call it rocket speed. I'm going to set it to something like 80. And then I'm also going to make it an int. I'm going to hard type it there. So it can't be changed. Okay. The other thing that we'll need is we'll need to get access to the rocket that we made. I'm just going to call this var rocket equals preload. And I'm going to drag from my Explorer down here the rocket. Okay, so there's 2 functions that we need to write. For me, I've got 2 functions on the player script called primary fire and primary fire released. So I'm going to need to implement both of those in order for this to work. I've got primary fire. I'm going to paste that in. pass. Whoop, stuff that up. Just type pass. And then primary fire released as well. Otherwise my game will crash. That, and we can just paste that in. Just call that. And I don't think I'm going to use that, it just needs to be there. Okay, the first thing we need to do is see if we're already playing the animation for shooting. InPlayer.isPlaying is the name of that function. And if it is, we're just going to return out. We don't need to spawn a rocket. If the animation player isn't playing, then it means we need to create a raycast and spawn a rocket. So what we're going to do is actually play the animation. So we'll write anim play shoot. And what we need to do after that is actually create a raycast from the camera. So we're going to write a new function called get camera collision. Right, and we're going to need two variables, one called ray origin and one called ray end. So for ray origin, we need to get access to the camera, the variable that we created earlier, and we're going to call a function called project ray origin. Pretty straightforward. And we're going to use the viewport. And we're just going to divide it by 2, which will give us the center of the screen. And then for the end of the ray, we're going to go open and close brackets, ray origin. And then we're going to add another function here called camera.project ray normal. And we'll also use the viewpoint here. And we'll divide it by 2. And then we'll just times that by an amount. I'm going to use 500. So when deciding how far to project the ray, you're probably going to need to take into account your camera. Now mine has only got a far view of 100, so after that you're not going to see the rocket. So I could make that number 500, and it would look like it's traveling to the center of the screen, but it's actually going to be traveling to a point way further down, and once it's past that, it's going to keep going that direction onto the other side of the crosshair. So it's worth keeping in mind exactly how that's going to look. I've got a video on that from last week. So we're going to use 500. Okay, now we're actually going to need to intersect that ray and return back the position of the intersection. So I'm going to call a variable called intersection. We're going to use a function called getWorld .direct space state, and then we're going to call a function called intersect ray, and it's going to need 2 positions. We've got our ray origin, not raycast, ray origin, and our ray end, and that's going to return an object if it collides with it. So what we need to test now is if not intersection dot empty, create a variable called col point, that is the position of the collision, and we'll set it to intersection dot position, and we'll return that point. Else, so if we didn't hit anything, we still need to return a position because we do need to spawn a rocket. So what I will do is return the end of the ray, and that's where I'll send the rocket. There's a couple of different options. If you want, you can just shoot it in a forward direction. I've tested that too. It looks all right. You can always watch my video from the previous week. Okay, so now that we've got that, I'm going to create a variable called target, and I'm going to set it to get camera collision. Then I'm going to create another variable called rocket direction, and I'll set it equal to the target minus the rocket point dot global transform dot origin and then I'm going to normalize it. So now we just need to actually spawn the rocket. So let's write a function for that. So I'm going to create spawn rocket, and I'm going to take a direction. I'll just call this dir. I'll make sure that it's a vector 3. And then I've got a few different things. I'm going to need to spawn the rocket at the world. So it's going to be the same as for the explosion. We'll go var w equals get tree dot get root. And then I've got the rocket itself. I'll use R this time, and I'll call rocket dot instance. And then all we have to do is go w dot add child R. So now what we need to do is set the position of the rocket and give it some force to move forward, because it is a rigid body after all. So we're going to go r.set global transform, and it'll be the rocket point dot get global transform. And then the very last thing that we need to do is r.set linear velocity. Can't spell. Set linear velocity, and it requires a linear velocity. So I'll go direction and I'll multiply it by a variable up here, rocket speed. Okay, now we've actually got the spawn rocket function. What we need to do is come back up into our primary fire and actually call that function. We'll go spawn rocket and we'll pass in the rocket direction. Okay, that's all there is to it. Let's jump into the scene and see if this works. Okay, it looks all right. Didn't see an explosion there, but there it is. Now you can see the objects reacting to it, and the enemies dying. So that's pretty cool. And if you don't hit anything, and it looks like I made a slight error and forgot to type return here. So we're just going to add that in, just in case you're wanting to make sure that doesn't happen. You can always type this little dash and arrow and vector 3 in this case, because we're trying to return a vector 3. So if you do make that mistake, it will actually throw an error and say a non-void function. So just a little bit of safety there if you make a mistake like that and you can't work it out. If you're trying to return a function, it's always good to have that so you don't make mistakes like that. Anyway, let's jump back in, and now it works perfectly. That looks pretty good. And so once you put all three things together, you get a rocket that will influence physics objects and also kill objects, which is pretty nice. Alright, I hope that's been helpful. I'm Isaac, I am Shaft Dev, and I'll see you in the next one.